Holy smokes, are you ready to dive in? We're going to focus on writing some exponential functions here tonight. And we're going to build everything off of our general form from the other day, y equals a times the quantity b, which is being raised to the x power. And just a quick emphasis, only the b is being raised to the x power. The a is not included in that power. It's just simply a leading coefficient. It's similar to when we wrote the equation of linear functions back in the day, and just that's a good question. We used to use the point slope form that looked like this, and that was for writing the equation of a line. Well, similar to that, where you only needed 2 points, and if you had 2 points, you had enough information to write that equation. The same thing applies today. So we're going to say any 2 points will uniquely determine the equation of an exponential function. And that's an important principle that we're going to build on throughout the video. So without further ado, we're going to jump right into our first live example. And it says, for the following coordinate pairs, we got a 0, 6 and a 254, find the equation of an exponential function in this form that passes through these pair of points. So here's what we know for sure right now. There is a particular function, and we could visualize, maybe here's 0, 6. And then here's 254 up here, and remember, it's not a straight line connecting them. It's more of an exponential function that maybe swoops like this. And we're going to try to come up with the equation of that line. And so the first thing we're going to do is we're going to grab that first point, and we're going to substitute the 0 for x, and we're going to substitute the 6 for y. So it looks like 6 equals a times the quantity b being raised to the 0 power. Now this is a very unique case. What we have right here is anything raised to the 0 power is simply 1. So even though we don't know who b is, the fact that any number raised to the 0 power equals 1 means that 6 equals a times 1, or in other words, a equals 6. So the fact that one of our ordered pairs had an x-coordinate of 0 was extra special, and that's why we're doing this one first, is that once you see a 0 here, you know that the 6 is what we call the initial value, and the initial value is always the value of a automatically. So we automatically know that y equals 6 times the unknown value of b raised to the x power, and now I'm going to substitute the 2 for x and the 54 for y, and by doing so, we'll see if we can solve for b. So we'll substitute the 54, and b is an unknown. Boy, my 6's and b's almost look the same, so hopefully you could tell those apart. And in an effort to solve for b, the first thing I'm going to do is I'm going to try to divide both sides by 6. Okay, I'm just undoing my order of operations, and then I'm going to take the square root of both sides. And one of the assumptions we are always making here, and this is worth noting, is that the value of b is always positive, okay? So in this case, b is only equal to positive 3. And to put the finishing touches, we'd say the equation is 6 times the quantity 3 raised to the x power. So that would be the final equation that corresponds to this graph right here. Well, our next example is very, very similar, but the first bad news is that our x values are 1 and 3. In other words, neither one of them is 0, so it's going to be a little more work on this particular example compared to the last one. So, but I'm staring at my standard form here, and I'm going to substitute a 1 for x and a 10 for y. And so 10 equals a times b raised to the first power, and that's all I could do with this. So I'm going to set it on the back burner and just let it chill for a little bit. And I'm going to use my other ordered pair, substitute the 3 for x and the 250 for y. And now 250 equals a times b raised to the third power. Now at this stage of the game, we're going to use a substitution method that we used earlier before the Christmas break when we were solving quadratic linear systems. And basically what the substitution method says is, really, you could pick either equation. What I'm going to do is I'm going to pick my first one just because the numbers are a little smaller, more manageable, and I'm going to solve for the letter A. Okay, so let's make that note here that we're going to try to solve for A. And in order to do that, I'm going to divide both sides by b to the first power. So 10 divided by b equals A. And now what I'm going to do is I'm going to take this 10 divided by b, and I'm going to substitute it for the value of a in the second equation. So now 250 equals 10 divided by b times b to the third. And what's going to happen here is I could say, well, b to the third is really b times b times b, and this b cancels one of those b's, so really all I have left is b squared. I'm going to divide both sides by 10 and then take the square root of both sides. So dividing by 10, let's see, first things first, right? 25 equals b squared. Again, we've in an exponential function, one of the rules that we don't talk about a lot about is that b has to be a positive value. All right, once you know what b is, we're going to use this value to work backwards over here and try to find the value of a. So 10 divided by 5 equals a, which in this case a equals 2. And then just before you're all done here, let's put it all together. And let's say y equals 2 times 5 being raised to the x. And remember, that's not equal to 10 raised to the x, okay? So I just want to clarify that. You're not allowed to multiply the 2 and the 5. Just leave it as is, and we'll never talk about that again. Again, another problem that's pretty similar to the first two, where they're supplying me with two, let's see what we got here. They're supplying me with 2 points, and I'm going to use these 2 points to write the equation of this exponential function. And notice this function is decreasing. And so the first note I'm making to myself is because this function is decreasing, that tells me that the value of b should be somewhere between 0 and 1. And if I get a b value that's greater than 1, then that's kind of a red flag that something went wrong. So we'll kind of keep that in our back pocket. But again, let's substitute the -2 for x and the 96 for y. Equals a times b raised to the -2 power. And then we'll do the same thing with the other ordered pair. We'll substitute them accordingly. And we'll say 6 equals a times b raised to the 2nd power. Okay, now, what are we going to do from here? Remember, you could pick either one of the equations. We're going to pick one of them and solve for a. Out of habit, I usually work off of the first equation that I have here on the left. Now, before I do solve for a, though, I'm going to use some of my exponent properties to rewrite this as a divided by b squared. Okay, and the reason I'm allowed to do that is because this exponent was negative, which allowed me to rewrite it with b being in the denominator. Now, when I cross multiply, I simply get 96 times b squared equals a. And now now that I've solved for a, I'm going to take 96b squared and I'm going to substitute it into the second equation. So that's that's something that's pretty normal, something we're going to do a lot of. 96b squared times another b squared. So this is really 6 equals 96b to the 4th, because I added those exponents. Divide both sides by 96, and we're going to have to reduce in this case. And if I reduce 9 divided by 96, I reduced it to 1/16 because they were both divisible by 6. And the next thing I'm going to do here, it's a little goofy. It's technically not the square root. What I'm doing is I'm taking the 4th root of both sides, and I do want to indicate that by putting a little 4 there in the index. And if you're not sure what the 4th root of 1/16 is, you're more than welcome to plug it into your calculator. I think if you hit the math button on the left-hand side, there's an option there for the xth root, and you could just type in the 4th root of 1/16, and you should end up with 1/2 equals b. Now remember, we still have to find the value of a. So what I'm going to do is I'm going to take this value of b, and I'm going to substitute it back in and solve for a. So we know 96 times 1/2 squared equals a, or 96 times 1/4 equals a, and I believe that's going to turn out to be a 24 equals a. So let's put it all together. The equation we're looking for is y equals 24 times the quantity 1/2 being raised to the x power, and that, ladies and gentlemen, is the final equation of an exponential function that corresponds to that graph. All right. Now that we've got a pretty good foundation underneath us, I'm going to give you a really, really messy question, okay? And the reason this one's so messy is because, see, up till now, all the examples we've done, the value of a and the value of b were rational numbers. And in this case, we're going to run into some irrational values of a and b, which means it's going to be very important to store our answers. Okay, as we work our way through the problem, we're going to store. And then at the very, very end of the question, what we'll do is we'll round our answers to the nearest hundredth at the very end. And so I'll write that down here on our screen at the very end. So it's not like, halfway through the problem I can, solve for b first, round that to the nearest hundredth, and then go solve for a, because that's going to affect the value of a. So first things first, we'll substitute the 2 for x and the 21 for y. 21 equals a times b to the second power. We're getting pretty darn good at this step of plugging everything in. 251 equals a times b raised to the 6th power. Again, you could pick either equation and solve for a. I'm going to pick the first equation, and I'm going to divide both sides by b squared. So in other words, 21 divided by b squared equals a. I'm going to take 21 divided by b squared, and I'm going to substitute it up here for a. So far, procedurally speaking, nothing has changed. 251 equals 21 divided by b squared times b to the 6th. Now what I'm going to try to do here is I'm going to try to simplify my b's. And I'm thinking b to the 6th divided by b squared equals b to the 4th. And now I'm going to divide both sides by 21. And here's my first encounter with a really, really messy number. Okay, so I've got, when I did 251 divided by 21, I got 11.95, yada, 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 okay? And what I did right now is I stored that bear as alpha A. Okay, notice I'm using a capital letter now rather than a lowercase letter, so I'm thinking that capital alpha A equals b to the 4th. And what I need to do now is the 4th root of both sides of the equation. And here, unlike the one we did earlier where a lot of us, we just did the 4th root of 1/16 in our head, we're going to definitely need the calculator here. And here's where, if you hit the math menu, and if you go to the fifth option on that screen says something like the xth root, and you want to grab that option. And once you're back to your home screen, you can type in the little 4 for the index and then alpha A, and what you should be getting is 1.85, let's see, 9360526, and that is the value of B. And I am going to go ahead and I'm going to store that as alpha B on my calculator. Now we're going to grab that value, unrounded, store it in its entirety, and substitute it back up here for B. And so now I'm thinking 21 divided by alpha B squared is going to equal A. And if I did 21 divided by B squared, I got 6.074241874. We got decimals coming out of our ears here. And I'm going to put it all together, and they said at the very end when I go to write my equation I'm allowed to round to the nearest hundredth, so I'm going to say 6.07 times 1.86 raised to the x power, and that's the equation we're looking for here. And I think the lesson learned is to take advantage of those store features on our calculator as we're working through the problem. Okay, so before we go real crazy on our calculator here, one of the things that we really want you to gain an appreciation for in this chapter is the power of exponential functions. And probably the most applicable thing to you and I is the way that we invest our money. And regardless of what career we choose down the road and where our passions lie, all of us are going to probably be at some point think about investing our money in some kind of, Roth IRA or 401k, 401b, something like that, something that pertains to the stock market. So we're going to talk about Molly and her investments. And what she did is she took $50 and invested that. So at t equals 0, she has $50. I'm using the letter A to represent the amount of money that she's accumulated. 1 year later, her money she'd gained $13 in the stock market, so her balance was now $63. 2 years later, it was worth $84, and then $137 and $252. And so, with a little bit of luck in the stock market, you can really stockpile your investments. So as far as an equation goes, we're thinking y equals a times b to the x, or we're going to tweak the notation here a little bit, and we're going to say a of t equals a times b raised to the t power is the format we're going for. But I'm going to teach you how to use your calculator here. So grab your calculator, and we're going to talk about how to do exponential regressions. You may have done a line of best fit or a linear regression in the past, and today we're going to talk about exponential regressions. So again, if you left your calculator in your bag, it's downstairs, wherever it might be, hit the pause button, go grab it, because we're going to need to practice finding these buttons. And the first thing we're going to do on your TI-84 is we're going to hit that stat button right here, center column, and I believe it's the second from the top. And once you hit the stat column, the edit's the very first thing we want, so we're going to then hit enter. And that's going to show you, hopefully you have an L1 and an L2. If there are numbers in these columns, you could just go ahead, highlight the L1, then hit clear. Just make sure you do not want to hit delete. Bad things are going to happen. So once you get those bears emptied, don't worry about the numbers that I have in my calculator here. What we want to do is we want to type in Molly's investment money into those columns. So it's going, L1 is going to consist of 0, 1, 2, 3, and 4, and then L2 will consist of 50, 63, 84, 137, and 252. Okay, once you get all that data entered into L1 and L2, what we're going to do now is we're going to go back and we're going to hit the stat button again. And that's going to show us a menu that looks like this, except instead of doing edit, we had to move over to calc. So once you're on the calc menu, you're going to scroll down until you see the 10th option there, which is an abbreviation for exponential regression. And so go ahead and hit that. Once you hit exponential regression, you're going to probably see a screen like this if your calculator is updated like mine was. And so we're just going to hit enter a bunch of times. Enter, 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 and until you have highlighted the word calculate, and we'll hit enter again. And then hopefully your screen's going to spit out something like this. You may or may not have this r squared and this r value, but everybody should have at least the a and the b value. And but the only trick is your numbers won't look like this one. It's just going to, the format of your screen is going to look like that. So let me tell you what my screen has for values. I had an A value of 44.02445329, and I had a B value of 1.4935, 64935. And now it's just a matter of dictating, what they want you to round it to. So let's say, just for practice, we'll do the nearest thousandth, which is 3 decimal places, and I'll go y equals 44.024. times 1.49, in this case 4, because we had to round up. Almost put a 3 there, raised to the x. And now what's useful is now you can use this equation, assuming that she gets a similar rate of return on her investment, she could say, okay, how much money would I have 10 years from now or 20 years from now? And you could simply plug different values in for x to experiment with how much money she could expect to have if the stock market was as favorable as it had been. So, all right, good luck tomorrow, and we will see you later.